Okay, for this set of notes, I'm going to talk about the leverage and then how to do these things in Wicca. So how to use lift and leverage as metrics in Wicca. So what I have on the screen right now is the definition for the leverage. It's definitely different than what we saw for the lift. And what jumps out about it is that it involves the same things. So the support of the rule, the support of the antecedent, and the support of the consequence. It's just that they're combined in different ways. So what we end up here is one where the values are a little different than the lift, but it's basically the same idea. And so when we see this definition, and it depends on the number of instances, so as a reminder, our rule is if x, then y, x and y are items, and we have a data set that has capital N instances in it, then this is saying, okay, count how many times it shows up and then divide by the number of instances. So that means we're estimating likelihoods. So that's the probability of both x and y being true. And then here we have the probability of x, the probability of y. It looks like I added an extra parentheses in there. Let's see if I can do something about that. And the answer is apparently no, I'm not coordinated enough to. But there we go. Good as it gets. So when we look at this, the way we want to think of this is we want to say, hey, we recognize this. This is what we get when x and y are statistically independent. So when we have a positive correlation, the hallmark of that is that the likelihood of x and y is actually bigger than the statistically independent prediction. And so what we get then is that we get a leverage that's positive. Likewise, when we get negative correlations, then the likelihood of x and y ends up just the way the numbers or the probability or statistics works out, ends up being less than that value. And so we get a negative leverage. And then when we actually get statistically independent, then those two things are going to be equal, like we know by now. And so the leverage ends up being 0. So leverage ends up being a useful metric because we can just look at the sign of it and we can say, oh, we know these things are statistically independent when they're 0 or close to 0. And then when it's negative, we know that's a negative correlation. And when it's positive, and then the higher the better, a positive correlation. So for association rules, we want things to be correlated. We want the antecedent x to be a good predictor for the consequent y. And so this is going to be the hallmark of interesting association rules. And so we would pick a threshold using leverage that's above 0. So then if we want to see how do we do this in